Welcome to Faith and Science. I'm Dr. John Ashton. Back many years ago, when I was at school, I can remember we were taught this gas model theory for the origin of the Earth, and it all seemed very plausible that all these gas clouds coalesced, and as they were spinning around the sun, formed the different planets and obviously Earth. And as it cooled down, obviously life came. Now it's very interesting that back then, and in the late 50s and early 60s, I was in a state school, but we weren't taught the theory of evolution, which was, I think as I look back, quite interesting. Even when I was studying geology at university in the early 60s, we weren't taught, as I recall, the theory of evolution as such. We were taught to identify the different epochs in time that were allocated millions of years in terms of their age. We were taught to identify those by characteristic fossils in paleontology, and the main thing, the main emphasis was identifying fossils at that particular time. And similarly in stratigraphy, again we were looking at how we could map the strata and work out the ages of the strata. So it's interesting how things have changed now. Of course, where evolution is a very dominant theory in our education system, despite now the overwhelming evidence from biochemistry that a complex molecule like DNA that just happens to encode the structure that is forming around it. If all these proteins and fats and sugars come together to somehow form somehow formed the first living cell for a molecule with a totally different structure, DNA, to be encoding that structure and all the directions to make that structure that's forming randomly around. I think just common sense tells it absolutely impossible. And scientifically it's absolutely impossible as well. But then, of course, it doesn't even stop there, because even if you had the code, you have to have a code reader system that matches that code, that is able to translate that code and then assemble the structure around it to make a new one, which is the ribosome, of course, that plays the role in that. And so, the evidence is overwhelming. Now, similarly, young people today are taught the Big Bang Theory, and also there was this massive explosion from where on of that space expanded from nothing, energy and matter expanded, and the energy converted into matter, and the matter condensed into the different stars and ultimately planets and so forth. And we often hear about people looking for evidence for life from outer space and this sort of thing. But one of the things that often is perhaps neglected is that space itself is very hostile to life. And, it's interesting when we send astronauts up into space, they face a lot of it's a very hostile environment with potential long-term hazardous health effects for those people. And as I think about this, there's overwhelming evidence for design in terms of the structure of our solar system and the location of where our planet Earth is in the solar system from a number of different aspects, and the whole structure of, it seems, of space and so forth is just overwhelming evidence for design, just as living systems are. When we look at the biochemistry of immunity and other things I've talked about in the past in living system, overwhelming evidence for design, blood clotting, all these sort of things, the reproductive system, systems of different plants and animals, overwhelming evidence of design, lock and key type systems, things that just match that. Again, random events just can't produce these sort of systems. And there's so many of them and they're so different. And so you've got so many random events that would have to have lined up that when we look at it, it's mathematically from the biochemistry and so forth, absolutely impossible. And I use the word absolutely. It's absolutely impossible. It wouldn't happen in a million, trillion, billion, zillion years. It's not going to happen. The systems aren't going to happen. The evidence for creation is just overwhelming. And one of the really fascinating areas is in the area of when we look in the area of the cosmos and the types of radiation, because the existence of life on Earth depends on precise, and I use that word in an informed way, depends on precise, non-coincidental arrangements of many natural phenomena. So a whole lot of things have to line up. And some of those things that sustain life are essentially, we can't see them. They're invisible to us. For example, you take the composition of gases in our atmosphere that allows us to breathe, and the plants to manufacture, food via photosynthesis and so forth, literally out of air. We get much of our food from the air. It's a combination of the carbon dioxide with water that forms the carbohydrates that the plant synthesise. It's amazing. And the compositions and the levels of these gases in air are just right. I know a lot of people are worried about the increased carbon dioxide content and the potential for increase of global warming. Well, it's just one factor that's involved. A lot of other factors that are involved in whether it's global warming and global cooling. But we forget that this carbon dioxide in the atmosphere is the source of our food. It's a source of food for the plants too that they grow. We need that carbon dioxide. Another factor is the ozone layer that protects life from deadly ultraviolet light. And we know there's a lot of concern about this some years ago because of the refrigerants and so forth that were used when they escape into the atmosphere, they react with ozone and essentially destroy the ozone layer in particular areas. And that's why I lived in Tasmania, that island state south of Australia there for some years. And I was always fascinated when I visited my mother in Cairns that I would sunburn more readily in Tasmania than up in Cairns in North Queensland, which is much heaps closer to the equator. But this was because over that southern part of Australia, particularly at that time, the ozone layer was relatively thin. Another aspect that protects our planet is our own planet's own radiation shield, which is called the magnetosphere. And again, this is a region that surrounds an object like a planet or a star, which is the extent of a very strong magnetic field in that planet or star. And the thing about magnetic fields is that they interact with charged particles and either deflect them or attract them. And it's interesting that several planets in our solar system have magnetospheres, but the Earth appears to have the most robust or strongest of all the rocky planets. And that was, if you're interested in looking up this, there was a very interesting article published in Space Science Reviews. It was back in 2005, but it was titled Solar System Magnetospheres. A very interesting article. The senior author was M. Blanc, B-L-A-N-C. And that was Space Science Reviews, volume 116, pages 227 to 298. Quite a significant review article there of about 70 pages. Amazing reference there. And so it's quite fascinating that the Earth's magnetosphere actually plays a vital role in the sustaining life on Earth. And it's really like a force field. And I guess most of us have done experiments at school where you take a magnet and you put a piece of paper over the top of the magnet and you sprinkle iron filings on it and they align. And you can see the effects of the magnetic field spreading out from that particular bar magnet. And, of course, magnetic fields are the principle behind electric motors that power our electric cars and diesel electric locomotives and, the motors in your blender and all these sort of things in our everyday tools that we use, electric drills and so forth. But one of the things that when we look at the way the solar system is arranged, we've got the sun there now. The sun, we all know, is extremely hot, but it produces a cosmic radiation that is continually bombarding our planet. Now, we think of the sunlight coming, the sun's rays, we feel its heat. We know that if we're out too long, we can get sunburned if our skin isn't climatised to the sun. And we associate this with the ultraviolet part of the spectrum. But there's also, just as we can't see the ultraviolet light, we also can't see the cosmic radiation that is coming from the sun. And this consists of various high-energy, tiny little particles. So we have electrons that are very, very, very tiny. They're the little negative charges that orbit around the outside of an atom that we learn about in school, and also other elements that have had their electrons actually ripped off, and that's particularly protons, which are the nucleus of a hydrogen atom where its electron has been removed, and also alpha particles, which are helium nuclei, and they're heavier because they have two hydrogen atoms combined with two neutrons, so they have an atomic weight of 4, and so they're quite high impact particles carrying a lot of momentum, the alpha particles. And it's interesting that, the article said that every second the sun emits about 1.5 million tonnes of high-energy particles. Now, of course, fortunately, they're radiating out in all directions, but some of these come towards the Earth. And the other thing that comes towards the Earth, of course, is what we call galactic radiation. And so we also get some radiation from other stars, like supernovas, which are stars exploding as they die and come apart. And, of course, cosmic radiation in the past used to refer to this. And this sort of radiation also can contain, other particles other than just hydrogen and helium. When these other high-energy cosmic rays impact our atmosphere, they can release secondary particles as well by colliding with other atoms in our atmosphere. So all these high-energy particles would be extremely damaging to life if it wasn't for the magnetosphere, deflecting most of these high energy particles from reaching us. And this is because of the laws of physics, that actually as these charged particles are moving through the magnetic field, they are repelled. And it's interesting that the other thing that is happening is that there's different bombardment between the daytime bombardment and the nighttime bombardment, because when you think about it, during the day, this part of the Earth that's experiencing daylight is facing the sun. And it's interesting that the magnetosphere facing the sun extends about 6 to 10 times the radius of the Earth, and the magnetosphere facing away from the sun stretches out a bit further. So it's actually quite interesting to see. It actually fluctuates in length and can even extend past the moon's orbit. So that's the Earth's protective magnetosphere can extend that far. And again, if you looked at a standard textbook on the magnetosphere, such as The Origins of Magnetospheric Physics by J.A. Van Allen, so that's a University of Iowa Press textbook, you can read some fascinating stuff about this magnetic field. And it's interesting, without this protective magnetic sheath, our planet would be damaged, be showered continually by these harmful rays. And that's why it's quite a radiation hazard for astronauts going into outer space and so forth, because this sort of radiation damages the DNA. This sort of radiation exposure can lead to cancer and actually hinder the generation of new cells. So it's very important that life be protected from this. Now, the Earth's magnetic field, which produces this protective effect, is actually generated by a circulating electric current in the planet's outer core. So the outer part of the core, and this electric current flows through the core. This massive electric current produces a field, this amazing magnetic field, but it is slowly decaying due to the natural resistance to flow. So as electricity flows through any conductor, whether it be copper, aluminium or iron, there's a certain amount of resistance. So different metals have different resistance. So a substance with very high resistance we call an insulator. But for example, if you remember those old bar radiators that have coils of wire, you plug them into the wall, switch them on, they begin to glow red hot. And the reason why they're glowing red hot is due to the current flowing through that particular element has a higher resistance, and so as the current is passing through, meeting that resistance, it loses energy as heat. And it's the same with the Earth's magnetic field. It's losing energy, which is dissipated as heat within the Earth itself. But we know now that the Earth's magnetic field has declined about 10% over the past 150 years, and it's exponential decline, which is what we would predict mathematically from the modelling of this decaying electric field in the Earth's core. And this is powerful evidence that the Earth is not millions of years old. If the Earth was millions of years old, the magnetic field would have decayed to nothing. We wouldn't have a magnetic field. And it's interesting that even within about 10,000 years, at the most, the strongest field should have decayed to nothing. which would have allowed cosmic rays to wipe out all of life on Earth. Now, this is a very, very important point that isn't taken into account, that the strengths of the Earth's magnetic field and the fact that it's decaying is powerful evidence that life on Earth is less than 10,000 years old. Because if it was older than that, the magnetic field would have had to have been so strong. And secondly, any length of time it would decay away to nothing, and life wouldn't be able to survive anyway. So this is a powerful design feature. But one of the fascinating things is that, and we get these solar winds from the sun itself that pass around. And one of the things, if you can imagine, that the sun itself is dragging our whole solar system through space. Now, as the sun travels through space, it's travelling through a very hostile environment. It's travelling through a hostile environment where the level of radiation of high-impact particles is about 40 times higher in outer space than it is within our own solar system. And one of the things that protects us from that, the massive particles coming just through outer space, which would also destroy life even more quickly, is what is called the heliopause. And so what happens is that it's quite fascinating that the sun, as it's travelling through space, is producing this shield of radiation, or solar wind, as it's called, from the sun. And you can imagine if you had, a ball of something that was emitting. Well, maybe think of a comet. As you have a comet flying through space, you've got this ball, and then you've got this tail behind it. Well, it's the same with the sun. The sun is emitting this cosmic wind, and out in front there's sort of like the bow wave of the sun, and it extends about 120 astronomical units. Now, an astronomical unit is the average distance between the Earth and the sun, right? So that's what is called an astronomical unit. So it extends out in front about 120 astronomical units, but it extends out the back. And so there's this tail of cosmic wind as the sun, dragging our solar system, charges through our galaxy and the universe, in effect. And we're enshrouded by this cloud of cosmic wind. Now, this cosmic wind is particles being emitted from the sun. And it travels out, as I said, about that far. And this huge bubble, or it's sometimes called the heliosphere, which, as I said, is about 17 billion miles or 27 billion kilometres in diameter, it's estimated there. And that shields everything, and that extends out past, all the planets. Now, what happens is, it's quite fascinating, that as this radiation is moving out, it suddenly almost abruptly stops. And this was discovered by Voyager 2. It's amazing phenomena. Because what happens there is it's meeting the incoming radiation, or the radiation coming in from outer space, which, as I said, is about 40 times higher. And so as those two opposing radiations meet, the sun's solar wind stops that radiation and greatly reduces that radiation from reaching us on Earth. And so here we find this massive design system that is just so finely tuned. There is quite an interesting report that was published in 2019 by M. Grashchenko, Greshko, M. Grashchenko. It's called Interstellar Space, Even Weirder Than Expected. NASA probe reveals. You can read the article on nationalgeographic.com. Came out on the 4th of November 2019. And essentially, the report explains that the protective heliosphere shields everything inside it, including our fragile DNA, from most of the galaxy's high-energy radiation. You know, and I was reading an article by a Dr. Jonathan Corrado about this, and that was published recently in Creation, Volume 44, 2022. And he says there, even though this world is fallen, evidence of design continually overwhelms our senses. So this is what Dr. Corrado writes. It does not take much rational thought to conclude that our material existence is the result of design in contrast to accidental evolutionary causes. From the macro to the micro, the elements of our material existence are finely balanced and operate with intricate shared precision. Some of the most remarkable findings of modern physics and cosmology, especially the indications that our universe and its laws seem remarkably tailored to sustain life, support this point of view of we are design. So there's amazing evidence in outer space that we are unique and designed. And of course the Bible talks about that. The Bible, description in the Bible, the description of origins, everything just fits so well with what we now observe. We are in an amazing created, not evolved, not big banged. We're in an amazing created universe. And the amazing thing is that the God, the amazing being that created that universe, wants a relationship with us. The Bible is full of answers to prayer and eyewitness accounts of answers to prayer and miracles. And the Christian literature published around the world testifies to this. And my own experience of answers to prayer and the knowledge of knowing that there's this amazing God of love that came as Jesus Christ and, you know, took our place in this wicked world so that God can forgive us and give us eternal life so that we never have to die. We can have an eternal relationship with God. I would encourage everyone, read the Bible, believe it. Get a Bible and start reading the New Testament and read these stories for yourself and pray, experience prayer for yourselves. Remember too, if you found this interesting, please tell your friends about these programs. Put up links on social media. And remember, if you want to re-listen to this program, just Google 3ABN Australia, or one word, .org.au, and go and click on the radio, the listen button. You've been listening to Faith and Science. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.